C++ and Java. Are they dinosaurs? Maybe an age. However, they still run a huge chunk of tech. C++ is the number 2 most used programming language according to the TIOBE index. Java is number 4. Today I'll show you where each language actually wins. C++ and Java, plus the modern sprinters, Python and JavaScript. By the end, you'll know which to pick for your next project or what to learn next. C++ is the performance engine when milliseconds matter. It powers real-time apps, video game and physics engines, trading, robotics, and embedded software. C++ is the language you reach for when time and memory truly matter. It gives you fine-grained control over resources, so you can tune latency and throughput down to the metal. With modern features, you get zero-cost abstractions, high-level code that compiles to tight machine instructions. It scales from tiny microcontrollers to high-performance servers, and you can interop cleanly with C and other native code. If you need maximum speed, predictable memory, and long lifecycle components, C++ is a proven foundation. C++ gives you control, but that control comes with complexity. You manage memory and lifetimes. Get it wrong, and you get undefined behavior, crashes, or security holes. Builds can be slow and finicky across platforms. Dependency management and ABI issues are real. The language is huge, so teams often mix modern and legacy styles, making code bases hard to onboard. And while performance is great, developer velocity can lag. However, sometimes that performance is so advantageous and problems have been mitigated enough that it's worth choosing C++. Is the learning curve steeper? Absolutely. But when fast enough isn't fast enough, C++ is the grown-up in the room. You pay with complexity, you gain hard, measurable performance. Java is the enterprise backbone. It's portable, scalable, and battle-tested. It is the language behind large backends, services at scale, and long-term support systems. Think payments, search, telecom, big retail, and countless internal platforms. The JVM delivers portability and smart runtime performance with JIT compilation, while garbage collection and robust concurrency APIs reduce footguns in large codebases. Its ecosystem is a powerhouse. Mature frameworks, enterprise-grade libraries, excellent IDEs, and battle-tested CI/CD pattern. Java's stability, predictable updates, and long-term support make it ideal for systems that must run for years. The hiring market is deep, the docs are extensive, and vendor support is abundant. If you want service resilience, maintainability, and a decade-friendly tech stack, Java is the safe, scalable bet. Java is steady, but it can feel verbose and ceremonial. Cold starts and JVM warm-up can hurt short-lived tasks. The garbage collector pauses are small now, but latency-sensitive systems still care. Memory overhead is hefty versus lean native apps. For rapid experiments, Java often feels slower to iterate. And while the ecosystem is massive, dependency graphs can get heavy and configs noisy. Despite all of this, its stability and power balance these negatives out enough to make it an obvious choice for many. Performance is often good enough with the JVM, and the payoff is predictable maintenance, long-term support, and a hiring pool that's battle-tested. Quick pause if you've enjoyed this breakdown. I put together a basics across programming languages poster. It compares C++, Java, Python, and JavaScript code syntax side by side. Perfect to keep on your desk or wall as a quick reference. Viewers of this channel get 10% off with the code DINOTON. The link's in the description. Alright, let's get back to the video. Python and JavaScript sprint for the speed of building apps and scripts. Python is a go-to for rapid development of data, AI, and automation scripts. JavaScript is the web's native tongue, especially for front-end frameworks and servers like Node.js. Python's clear syntax and dynamic typing help you prototype fast, iterate often, and ship utilities in hours instead of days. Its ecosystem for data science, AI, ML, analytics, scripting, and automation is massive. Interop is a strength. You can call native extensions for speed-critical pieces and keep Python as the glue that ties systems together. The standard library is generous, third-party packages are abundant, and community learning resources are everywhere. JavaScript is the language of the web, and that ubiquity is a superpower. It runs in every modern browser, letting you build interactive interfaces that reach users instantly. With Node.js, the same language powers backend APIs, CLIs, and real-time apps, so teams can move quickly full stack. The module ecosystem is enormous, and modern tooling supports bundling, testing, and deployment at speed. The event-driven, non-blocking model is built for I/O-heavy workloads, from chat to streaming dashboards. Do these always beat Java or C++? No. Python is fast to write, but not to run. Dynamic typing speeds, prototyping, but pushes some bugs to runtime. Packaging and environments can be messy across OSs. Shipping desktop apps is non-trivial. For always-on, high-throughput services, Python can require more machines or careful offloading to C, C++. JavaScript runs everywhere, but it brings quirky semantics and type pitfalls if you're not disciplined. Less so with TypeScript, but it's extra tooling. The ecosystem moves fast. Dependency churn, tooling fragmentation, and NPM bloat are common. In the browser, security pitfalls like XSS lurk. On Node, the single-threaded event loop struggles with CPU-bound tasks unless you offload to workers or native modules. Despite all that, Python and JavaScript have clear development advantages and perks that make even these weaknesses minor for that speedy development time. For iteration speed, front-end reach, and glue code workflows, they're hard to beat. Here is the spectrum each one is on. C++ is for low latency and efficient code, Java for sustainable and scalable enterprise applications, Python for scripting and data science experimentation, JavaScript for web-native application. You don't have to worship one language. Great teams stack them. C++ for a core engine, Java for services, Python for data pipelines, JavaScript for the product experience. So yes, Java and C++ are dinosaurs. But in the ecosystems that run our lives, C++ and Java are still apex predators, alongside Python and JavaScript. Different strengths, one ecosystem. Thanks for watching. Comment below on the languages you really think are dinosaurs, and hit subscribe to watch more videos about programming languages here.